In this video, we're going to be talking about problem 4a, where we're writing this constructor for the LightBoard class, which initializes lights, which is this private field that we have within the class that represents the lights on the board, where true is on and false off. And basically, within this constructor, we have this condition that every light within the LightBoard has a 40% probability of being set to be on. So we're going to have to do a few things inside the constructor to make sure that it is ready to go when someone initializes it as an object. Let's go ahead and start off with some pseudocode. So we have this field lights, which is a 2D array, and we're probably going to want to initialize it. Initialize the lights array. Why do we want to initialize it? Well, we're going to want to be setting the values inside of it. So we're going to want to loop over the 2D array and then within that 2D array, every single value inside of every row and every column, we're going to want to determine whether the light should be on or off. So for every value, for every light on the board, calculate the probability of it being on. And then once we have that probability, we're going to want to actually set the value at that index to be either true or false based on if it's on or off. Set the value at that index to be on, true, or off, false. And then we don't return anything in this method because it's a constructor and we're basically just initializing this internal state. So once we do that for every single light on that light board, we should be good to go. Let's go ahead and dive into the actual code here. So first thing we're going to want to do is actually initialize the lights array. Right now we have this field light, so we see that it's a 2D array of booleans, but we haven't actually initialized it. So we're going to want to set lights equal to new and then boolean. We need to say that type again. And then we're going to have two square brackets, and what's going to be within those square brackets is first the number of rows this 2D array has, and the second one is going to be the number of columns. So luckily that's being passed in as parameters here, num rows and num cols. And that should be it for our initialization. The reason why the order of this actually matters, so if you were to put num columns first here and then num rows here, you would get a 2D array that isn't the proper size. Make sure to remember that 2D arrays are row major. So the row comes first. The next thing we want to do is actually loop over this 2D array. So for this, we're going to want some nested arrays. So for int I equals 0, I is less than, okay, so as I just mentioned, 2D arrays are row major. The outer loop is going to be looping through the rows. So we're looping from 0 to I is less than num rows. Our rows are 0 indexed, so we want to keep going until we've looked at every single row. And then we're going to be looking at the rows one by one. Okay, so that's our outer for loop, taking care of the rows. Our inner for loop is going to be taking care of our columns. So we have to use a different variable name here. We can't use that I, otherwise we're going to be messing up the order of the rows. Might even run into an index out of bounds error. So similar for the inner for loop, but now we're going to be doing it based off the number of columns. Now that we're inside of the inner for loop, we know that if we grab lights at ij, that is going to be an actual value, an actual boolean that we can set, because our outer for loop was indexing the rows and our inner for loop is indexing a specific column within that row. So we're going to be getting a value here. So now we need to do a little bit of math. We are given this condition that every light has a 40% probability of being set to on. So this is where we can look into our list of methods that are available to us and see if there's anything that gives us any sort of randomness. If you looked at that list and you thought, okay, well, math.random really seems like a good candidate, you would be absolutely correct. So math.random returns a double from 0 to 1, where 0 is inclusive and 1 is exclusive, so it doesn't return 1. So from 0 to some number that's just below 1 is going to return some value. So we can go ahead and set that to a double. So let's say double probability equals math.random. And now we don't even need to modify this math.random value at all, because we can just use this concept of the fact that it returns a value from 0 to 1 exclusive to determine if our light should be on or off. So how am I going to do that? With an if statement. So if the probability is less than 0.4, this should happen roughly 40% of the time, then we know that at lights of I of j, that value should be on. It should be true. Otherwise, so that would be if probability is greater than or equal to 0.4, lights at I, j should be false or off. If you look a little closely, we can kind of simplify this a little bit as well. So notice that this is going to return either true or false, and then we're setting the value at lights of ij to be true or false. So we can actually even just say something like this: lights at ij is prob less than 0.4, because this is going to return true or false, and that is exactly the value that we're setting there. So we can get rid of the if structure if you want. As far as testing this, unfortunately, it doesn't give you a sample input and sample output. So what I did is I just plugged this into a Java playground. So here it's not really a class, but this is just for the purpose of showing you. But basically, I have this turn lights on method that accepts our number of rows and number of columns. And then here's the solution to part A, and it'll return that 2D array. And then it will print it using this print matrix method. So this is all just for showing. And then you can see how the matrix changes. You can see, I mean, roughly 40% of the time, you're going to be turning lights on to true. And then you can see that it can change as you change the number of columns, and you change the number of rows, so on and so forth. If you get rid of all the pseudocode, here is what our solution looks like, where we're initializing that internal state, that lights array. We're passing in the number of rows and the number of columns we anticipate this array to have. We're looping through all the rows and all of the columns to index every single value within the LightBoard. We're grabbing a probability from 0 inclusive to 1 exclusive, and then we're using that probability to determine whether that light should be turned on or off. So 40% of the time, the light should be set to on, and then the other 60%, it should be set to off or false. And that's all there is to it. I hope this helps you out with this 2D array problem. If you have any questions, feel free to leave them down below, and I'll get back to you. And I hope you have a great rest of your day.